Yes, our today lesson is on photoelectric effect. In this topic, we will discuss the following subtopics: photoelectric effect, photons, threshold frequency, work function, Planck's constant, and electron volt. Then we'll move to factors affecting photoelectric emission, photons, Einstein equation, application of photoelectric effect. Now, an introduction will say, when light with a frequency that has sufficient energy is radiated on a metal surface, electrons are emitted. This phenomena has wide applications in life, such as construction of solar panels for green energy and automatic counter streets, controls, and alarms. So, we want to move to what we are talking about. When light is incident on a metal surface, we have the setup here. We have light. This is a metal surface connected to a source, EMF source. So I want to say, let me make this side be more positive, around 3.2 volts. Then this side becomes positive, this one becomes negative. There is a metal surface here, and when we do like that, there is no current recorded. But if incident light on this metal surface, let's see what happens. We increase the intensity. You see electrons are ejected. Look at that. The electrons are emitted from here and they are accelerated towards the anode. That's what we are saying, that when light with a frequency that has got sufficient energy is radiated on a metal surface, electrons are emitted. That's what we have seen here. Light instead of a metal surface, on a metal surface with sufficient energy, electrons are emitted and they are attracted towards the anode. Now we move to the factors affecting the electrons that are going to be emitted. Now these factors, we look at them in terms of experimental setup. The first factor we look at is what happens if we increase the intensity of light. So if we increase the intensity of light, you will see more electrons are ejected. That's why we are saying, when the intensity of light is increased, more electrons are ejected from the metal surface. Explanation. Increasing the intensity of light implies that more energy reaches the metal surface. The energy is used in ejecting more electrons, which are attracted to the anode. Move to the second factor. If we use different surfaces, different metal surface, like for example, this is sodium. I want to change it to, for example, zinc. The moment I change this one to zinc, no electrons are ejected. Even if I increase the intensity to the last one, no electrons are ejected. If I change this metal surface to copper, nothing is ejected. If I change this one to calcium, you will see electrons are ejected, but very few as compared to sodium. So what is it? We say, by using different metal surfaces, it is observed that different intensities of the emitted electrons are achieved. The least emission of electrons is achieved when we use nickel, while lead has got highest emission in the same light intensity. Like here we used sodium and calcium. So the energy required to remove an electron from a metal surface differs from one metal to another. Move to the next factor. When different frequencies of light. With different frequencies of light, we turn back to sodium. We have sodium there. And we have the intensity there. I want now to adjust the frequency by adjusting the wavelength. We adjust the wavelength, 463 nm. Look at that. We adjust the wavelength, the number of electrons are reducing. This color. See that? At this point, no electrons will be ejected. But if we go to here, electrons will be ejected. So what are we saying? With the different frequencies of the incident light, the number of electrons emitted is seen to vary. Higher frequencies emit electrons with higher energies. I want to come back here and explain what it means. This experiment was done by Albert Einstein by using the setup we have described here. And what is the effect of light intensity as per what we observed here? Correct. What effect does the color of light have? You saw I was varying the wavelength, and you saw what happened. As I increase the wavelength, fewer electrons are ejected. Why do electrons given off have got a range of energies? Maybe I didn't show that one. You can see that electrons that are ejected do not move at the same velocity. I want you to look at that. They don't move at the same velocity. Look at that. There are some that move at a very high velocity than the rest. We will answer that one today. So that is the setup we have used. That's the setup we have used. And we want to say that this gap here, it is through incident light that makes the electrons to be ejected, and they are attracted, they are not, that makes the circuit complete. So we want to say this. Laws of photoelectric effect. The number of photoelectrons is proportional to light intensity. Less intensity, fewer electrons. More intensity, more electrons. Each metal has got different threshold frequency below which no photoelectrons are emitted. Each metal has got required different amount of energy for an electron to be ejected out of the metal surface. We will discuss that one in a few minutes. A range of energy is produced, but the maximum value depends on the color. So I want to have wave theory can't explain why color is the most important factor in the photoelectric effect. It predicts that intensity should be the main factor. So I want to start explaining actually what happens. Main activity. Look at this one. These are the three balls here. Give ball 1 50 joules. That is how far it can reach if it was to rise. Give it 8 joules. That is how far it can reach. Give it 100 joules. That is how far it can go. Give ball 200 joules. Hope you have seen where it reaches. Give ball 200 joules. It's when it will reach the other one. Give ball 300 joules. Give ball 200 joules. Give ball all the balls 200 joules and see what happens. 200, 200 for that one, 200 for that one. So what is it? The balls emerge with different kinetic energy depending on the position they are in. This one will go far because it's just above here. This one will move this way because it was very deep. And we want to explain that one what Einstein used. Einstein explained the photoelectric effect by assuming that light is made up of photons, each with an energy given by the Planck's constant, Planck's equation, Planck's constant times frequency. So we want to assume that these are the photons. This is a metal surface and it has got electrons. So what happens? So a photon comes, knocks an electron, and an electron is ejected. Depending on the position where it is. Look at the various positions they will be ejected. They emerge with different energy. This is much deep. It does not even get out. This one goes to that level. This one here goes to this level. This one here move to this level. Correct? This one here move to this level. These are photons, huh? Correct? Seeing that? This one is just close to the surface. It goes the highest. The electron use some energy to escape from the metal and so escape with a range of kinetic energy. Want to start. This electron is far below the surface and needs a lot of energy to escape. It emerges with very little kinetic energy. So the energy the photon brings in makes an electron to move from the position where it is to the surface, then move out of the surface. Yeah? This electron is so far below, and therefore it does not get enough energy to escape. This electron is close to the surface and escapes with very lots of kinetic energy. Energy of a photon is given by Planck's constant times the frequency of the radiation it comes in with. Now, the minimum energy required to knock an electron from the position where it is to bring it to the surface here, the minimum energy to knock an electron out of the metal surface is called the work function. That means if this energy here is more than the work function, chances are the electron, the excess energy will make the electron escape with kinetic energy. Depending on the position where it is, it will have maximum kinetic energy depending on the position where it is. This one here, the maximum energy of the photoelectron is the difference between the photon energy and the work function. Photon energy and the work function, then you will get the kinetic energy. From here, guess from here to here, and then the kinetic energy. Now, instant photoelectric equation. The energy of a photon is always equal to the work function plus kinetic energy. So what does it mean? To get kinetic energy, it will be energy of a photon minus the work function. Conditions. All metals have got different work functions. That's why you saw sodium 2.36 and I used what? Calcium. If you are using copper. Copper is 4.48 and therefore requires a lot of energy. Its work function is higher than sodium, therefore requires a lot of energy for an electron to be ejected. Every metal has got its own work function. Now, the emission of electrons from the surface can only occur if the energy of the photon is greater than or equal to the work function. If it is greater than the work function, it will escape with kinetic energy. If it is equal with the work function, the kinetic energy will be zero. Mathematically, that tells you that the frequency of the incident radiation must be greater than the work function divided by the Planck's constant. This is a constant. If the frequency is equal to the work function divided by that That will be the minimum frequency with which the electron, the incident radiation should have to come in with to eject an electron. The threshold frequency is the minimum frequency required for an electron, for an emission of an electron. Now, just go direct to what we were talking about. Look at that. If we change this one to copper, copper requires a lot of energy. Now we are saying that this incident radiation here is in form of photons. The energy is coming in form of photons, and the knocks electrons, the electrons to be ejected. With that very good summary, I want to make a summary by saying that under this, we say factors affecting the photoelectric emission is the intensity of the radiation, type of the metal surface because of the different work functions, and the frequency of the incident radiation. We have talked about photons, that electromagnetic waves such as light travels in form of packets of energy called photons. And that's what I was saying here. These are photons. Knocks electrons and electrons are ejected. In that case, the packets from the particular wave carry equal amount of energy. We have seen that. Then we're talking about threshold frequency. This is the minimum frequency of light below which no electrons are ejected from a metal surface, no matter how intense the light is. This is represented by this. Let's see that. Coming in to eject an electron. For the case of visible light. UV light, you see electrons are being ejected. That means the frequency with which the incident radiation comes in with. I've defined what we call work function. This is defined as the least energy required to eject an electron from a metal surface. It can be calculated using the equation Planck's constant times the threshold frequency, and denoted by this letter W subscript naught. The work function varies from one metal to another. With those very few remarks, I want to say that we have done well. And under that introduction, before we move to calculations, I want you to look at what we have talked about, and from there we will proceed on calculations with that kind of basic information. Thank you.